Okay, so number one, let's suppose we had the square root of 5x minus 1 minus 2 equals 3. All right, so this is a radical equation. So it's sometimes called a radical equation. In this case, though, the radical is the square root. So you have the square root equation. Okay, then to solve a radical equation, the first thing you have to do is get the radical symbol by itself. So that's step one. So when you look at the lessons that go with week 15, it talks about those steps. So the first thing you got to do is get the radical by itself. So I'm going to add 2 to both sides. And so when I add 2 to both sides, I get the square root of 5x minus 1 equals 5. 3 plus 2 is 5. Now, once you get the square root by itself, remember you're trying to solve for x. So the next step, when solving a radical equation, the next step is to raise both sides, this side and this side, to a power, to an exponent that's equal to the index. So since this is square root, the index is understood to be a 2. So you're going to square both sides. So in all these problems, these are all square root equations. So in every problem, you're going to square in every problem because this is a square root. If this was a cube root, you would cube both sides. If this was a fourth root, you would raise both sides to the fourth power, and so on. All right, one of the things you learned is that when you square a square root, those undo each other, and you're left with 5x minus 1. Kind of makes sense because if you have, let's say, the square root of 6 squared, like this. Well, the square root of 6 squared means the square root of 6 times the square root of 6, which is the square root of 36, which is 6. So the square root of 6 squared is just 6. It's just that radicand because the square and the square root undo each other. So you're left with a radicand. So that same idea applies when you have a variable expression. So now what you have is this. You have 5x minus 1 equals, and then 5 squared is 25. So now I went from a square root equation to a linear equation. And so I'm going to add 1 to both sides. So I get 5x equals 26. And then you divide both sides by 5. And so you get x to be 26 fifths. Now, one of the things you got to remember is that when you raise both sides, of an equation to an even power, or an even power, you may introduce extraneous solutions. And sometimes we'll call the word extraneous false. So false solutions. So basically, you see how it went from a square root equation to a linear? Those are two different types of equations. So 26 fifths is a solution to the linear, but it may or may not be a solution to the original. So when you raise both sides of an equation to an even power, you have to check your solution into the original. So when we go through some more of these problems, you're going to see how this applies. You are going to end up with some extraneous solutions. So again, you are going to need to check to see if this is an extraneous root. Another word for solution is root, R-O-O-T, or a false solution, or a false root. Always go back to the original. So let's check x equal 26 fifths. So go back to the original. So the original was the square root of 5x minus 1, subtract 2, and then I want to see if that's going to equal 3 when I substitute 26 fifths. So when I substitute 26 fifths, I get the square root of 5 times 26 fifths minus 1, and then I'm going to subtract 2, and I'm going to see if that's going to equal 3. So I want to see if this side equals 3. Well, 5 times 26 fifths, the 5's divide out, and then 26 minus 1 is 25. So I get the square root of 25 minus 2, and then the square root of 25 is 5, and 5 minus 2 is equal to 3. All right, so this works. So that's our solution. So this is not an extraneous solution. This actually is a solution. All right, so that's number one. So that's how you do these. So the idea is when solving a radical equation, in this case it's a square root, you got to get the radical by itself. then you raise both sides to a power equal to the index, and then you go from there. If you raise both sides to even power, you have to check. All right, that was number one. Let's look at number two. So in number two, we have this problem for number two. Let's see. Let me go ahead and move this. All right, number two. So let's say in number two we have the square root of x plus 4 minus 3. Let's do plus 3. Plus 3 equal, let's say, 7. All right, square root of x plus 4 plus 3 equals 7. So again, I want to solve this square root equation. So I got to isolate that radical by itself, because at some point I want to get x by itself. So I'm going to subtract 3 from both sides. And I subtract 3 from both sides, I get add the square root of x plus 4 equal, and then 7 minus 3 is 4. Okay, now I'm going to square both sides. So remember, once you get the radical by itself, you got to get rid of that square root symbol. So to get rid of that square root symbol, you're going to raise both sides, which you do to one side, you do to the other, to a power equal to the index. Well, all of these are square roots. So you're going to square both sides. And when you square both sides, the square and the square root undo each other. So you're left with x plus 4 equal, and then 4 squared is 16. And then subtracting 4 from both sides, I get x equals, and then 16 minus 4 is 12. Now I did raise both sides to an even power, so I need to check 12 into the original problem. So we have to check x equal 12. So we're checking for extraneous roots. So I get the square root of x plus 4 plus 3 equal 7. So in place of x, I'm going to substitute 12. So I get the square root of 12 plus 4. And then I'm going to add 3. I'm going to see if that's equal 7. Well, 12 plus 4 is 16. The square root of 16 plus 3, and the square root of 16 is 4, and 4 plus 3 does equal 7. So this is a solution. All right, number 3. In number 3, we have 3 times the square root of 2x plus 1 plus 5 equal 29. All right, so again, I have to get the I have to get the radical by itself. Now, this 3 out here is going to be a little bit tricky for some of you. But first thing I'm going to do is subtract 5 from both sides. And when I subtract 5 from both sides, I get 3 times the square root of 2x plus 1 equals, and then 29 minus 5 is 24. Now, remember, you're trying to get the radical by itself. That's the best thing to do. So right now I'm multiplying it by 3. So what I would do next is I would divide both sides by 3. So that's the next step. Divide both sides by 3 so you can get that radical by itself. 3 divided by 3 is 1. So I get the square root of 2x plus 1 equals, and then 24 divided by 3 is 8. And now, once you get the radical by itself, you're going to raise both sides to a power equal to that index so you can get rid of that square root symbol, because I'm trying to get x by itself. So to get x by itself, you got to get rid of that square root symbol. The only way you can get rid of that square root symbol is to raise both sides to a power equal to the index. In this case, square root, the index is 2. So you're going to square both sides. So the square and the square root undo each other, so you get 2x plus 1 is equal to 64. And then you subtract 1. And so I get 2x equals 64 minus 1 is 63. Divide both sides by 2. I get x equal 63 divided by 2. Okay, so once you get x equals 63 divided by 2, once you get x by itself, remember you raise both sides to an even power, so you have to check. So let's go back and check this. Okay, so since I raised both sides in even power, I have to check in the original problem. So let's go ahead and check. So check the original problem. So we're going to check x equals 63 divided by 2. And then you go to the original. So I have 3 times the square root of 2x plus 1 plus 5 equals 29. And in place of x, you're going to substitute 63 divided by 2. So I get 3 square root of 2 times 63 divided by 2 plus 1. You're going to add 5, and you want to see if that's going to equal 29. So you're checking to see if the left side equals the right side. The 2's divide out, 63 plus 1, 64. So I get 3 times the square root of 64 plus 5. The square root of 64 is 8, so I get 3 times 8 plus 5. 3 times 8 is 24. 24 plus 5 is 29. So this works. All right, so that's number 3. Let's look at number 4. All right, now number 4, and so notice that in those 3 problems, I went from a square root equation to a linear equation. In every single one, a square root equation to a linear. In the next, well, the next one is as well. So the same thing will be in number 4. So let's look at number 4. So number 4, we have, let's see, we have the square root of 3x minus 2 plus 8 equals 2. All right, now, so again, I want to get the radical by itself. So I'm going to go ahead and subtract 8 from both sides. All right, and when I do that, I get the square root of 3x minus 2 is equal to, and then 2 minus 8 is a negative 6. Now, here's what some students are going to do. So, and for the reason that we did in the previous ones. So you're trying to get the square root by itself. And I'm going to go ahead and do this, and then I'm going to come back and talk about this part right here again. So what many students are going to do is this. They're going to go ahead and square both sides to get rid of that square root symbol. And when they do that, the square and the square root undo each other, so you get 3x minus 2 equals, now be careful here, negative 6 times itself is a positive 36. So now you're going to add 2 to both sides, and so you get 3x equal 36 plus 2 is 38. And then divide both sides by 3, I get x to be 38 thirds. But remember, since I raised both sides in even power, you need a check. So we must go and check. So you check x equal 38 divided by 3 into the original problem. So the original problem is 3x minus 2 plus 8, and let's see if that's going to equal 2. So this becomes the square root of 3 times 38 divided by 3 plus 8. So that's your left side. Your right side, you want to see if this is going to equal 2. The 3's divide out, so you get the square root of, I forgot to subtract 2, I'm sorry. I forgot to subtract 2. So you get 38 minus 2, which is 36. So you get square root of 36 plus 8. The square root of 36 is 6. Now notice 6 plus 8 is 14. 14 does not equal 2. 14 does not equal 2. So what that means is that this right here is an extraneous solution. Extraneous solution. And that means this. That means that 38 divided by 3 is a solution to this linear, but it's not a solution to the original. And you see that whenever you raise both sides of an equation to even power, you sometimes introduce false solutions. So that's why you have to check. Now, since that was our only proposed solution, and it turns out to be a false solution, then we say our answer will be no solution. So this equation has no solution. So that's what you would write. You would write no solution. Now, I want to mention this. So let me go back, and you remember, let me go back and redo it. So you have the square root of 3x minus 2 plus 8 equals 2. Okay, so you remember a while ago we subtracted 8 from both sides, and so you got the square root of 3x minus 2 is equal to negative 6. Well, you see this square root here, that's a positive square root. See that? I'm dealing with a positive square root. So this side's always going to be positive. A positive is never negative. So right away, you could have said no solution. Right away. Because this is always going to be a positive number. No matter what you substitute to x, as long as this radicand is positive or 0, the square root of that number is always positive. And a positive is never equal to negative. So you could have said no solution right away. But many students don't think of it like that. They just go through the process. So you square both sides, you get x by itself. Since I raised both sides to even power, you have to check and notice that this proposed solution is actually an extraneous solution. And so therefore you say no solution. All right? Okay, that was number 4. So let's do number 5. In number 5, we have the square root of x plus 3 equals x minus 3. Square root of x plus 3 equals x minus 3. Now, in all the problems we've done, if you go back to all those 4 problems, we went from a square root equation to a linear. It was always linear in every single problem we've done. I went from a square root equation to a linear equation. That's linear. Every single one. Now, if you look at number 5, the radical is already by itself. Let me go ahead and rewrite this over. Since the radical is already by itself, I want to get x by itself here, right? And notice there are x's on both sides. So just as before, I need to get rid of that square root symbol though. So I'm going to square both sides, just like this. Make sure when you square the other side, you put all those terms in parentheses like I did. And now what you have is this. So just as before, the square and the square root undo each other. So that's x plus 3. But notice what you have over here. In the previous problems, if you go back to the previous problems, you just had a number, right? And so you just square that number, and that was easy. You get 64 in this case. Over here, when you squared 4, you got 16. But here, you don't have just a number. You have a variable expression. It's a binomial, but you have a variable expression. So you got to square this binomial. So you're going to FOIL this. So you get rid of that parentheses, and notice that x minus 3 squared means x minus 3 times itself. So you're gonna FOIL. So x times x is x squared. The outer is a negative 3x. The inner is a negative 3x. And the last, a negative 3 times a negative 3, is a positive 9. Combining like terms, I get x squared minus 6x plus 9. That goes here. X squared minus 6x plus 9. Notice again in the previous 4 problems, I went from a square root equation to a linear. In all the previous 4 problems, I went from a square root equation to a linear. Okay, so now we have this quadratic equation. So I went from a square root equation to a quadratic. And so to solve this quadratic equation, let's go ahead and bring all the terms to one side, and we'll go ahead and bring them to the right-hand side, since x squared is on this side. So I'm going to subtract x from both sides. So I get 3 equals x squared minus 7x plus 9. It's negative 6x, and negative x is negative 7x. Subtracting 3 from both sides, I get 3 minus 3 is 0. So I get x squared minus 7x. And then 9 and a negative 3 is a positive 6. All right, and so now what we're going to need to make sure, I think I made an error somewhere. Oh, that's 7x, I'm sorry, minus 7x. Okay, so minus 7x. All right, so then these are going to be factorable, so let's go ahead and factor this. And I'm going to go ahead and transpose the sides. So I get x squared minus 7x plus 6 equals 0. Okay, factoring, I get x minus 6 times x minus 1 equals 0. Okay, and then I'm going to set each factor equal to 0. So I get x minus 6 equals 0, x minus 1 equals 0. And so I get x to be 6 and x to be 1. All right, now remember, you raise both sides to an even power. So you have to check for extraneous solutions. So you got to check both of those into the original. Okay? So let's go ahead and check x equals 6. So you're checking for extraneous solutions. So let's check x equals 6. Okay, so go back to the original. So the square root of, the original is this right here. So it'll be the square root of x plus 3 equal x minus 3. So in place of x, you're going to substitute 6, and you're checking to see if this side equals that side. And so I get the square root of 6 plus 3. And on this side, I get 6 minus 3. 6 plus 3 is 9, right? So we have the square root of 9, and the square root of 9 is 3. On this side, I have 6 minus 3, and notice those are equal. So x equals 6 is going to be a solution. So I'm going to go ahead and circle that one. Now let's check x equal 1. So check x equal 1. So when we check x equal 1, I get, let's go back to the original. So I'm going to rewrite the original over. So square root of x plus 3 equal x minus 3. So this time in place of x, I'm going to substitute 1. So notice I get the square root of 1 plus 3. And on this side, I'm checking to see if those are equal. On this side, I get 1 minus 3. Remember, the square root of, first of all, 1 plus 3 is 4, so the square root of 4, and the square root of 4 is 2. Over here, though, look what you have. You have 1 minus 3, which is a negative 2. Those are not equal. Those are not equal. So that means that this x equal 1 here, that happens to be an extraneous solution, a false solution. See, x equal 1 makes this quadratic equation true. That's a true statement. It is a solution to this quadratic equation, but it is not a solution to the original. So the only solution is x equal 6. That's the only solution. So that's what you would circle, or you would write in the blank. All right. But notice you had to show that you checked for extraneous solutions. And you do that whenever you raise both sides to an even power. All right, so that's number 5. Let's look at number 6. So number 6, we have the square root of 2x plus 5 minus 1 equals x. All right, so right now, remember that you got to get the radical by itself, so I'm going to go ahead and add 1 to both sides. Add 1 to both sides. So I get the square root of 2x plus 5 is equal to x plus 1. X plus 1. All right, now remember I want to get rid of that square root symbol next. So since the radical is already by itself, I'm going to go ahead and square both sides. Notice how this looks. You're squaring x plus 1, so the x plus 1 is in parentheses. The square and the square root will undo each other, so you get 2x plus 5 equal, and then when I square x plus 1, remember what that means? That means x plus 1 times itself. And if I FOIL this out, I get x times x is x squared. The outer is x. The inner is x. And then the last, 1 times 1 is 1. And so I get x squared plus, and then x plus x is 2x, and then plus 1. So this goes here now. So x squared plus 2x plus 1. So just as the previous problem, I went from a square root equation to a quadratic. See, that's quadratic right here, a quadratic equation. And so when I solve this quadratic equation, I end up with 2 proposed solutions. This one worked. This was extraneous. That was a false solution. So the only solution was 6. The same thing here. I went from a square root equation to a quadratic. See, that's a quadratic equation, right? And remember, to solve a quadratic equation, you got to put this in standard form or general form, and then either factor if it's factorable, and the ours will be factorable, or you can use a quadratic formula. So let's go ahead and subtract 2x from both sides, and notice what happens when I subtract 2x from both sides. I get 5 equals, no, see this right here, 2x minus 2x is 0, right? And so I get x squared plus 1. Subtracting 5 from both sides, I get 0. 5 minus 5 is 0, equals x squared minus 4. Okay, I'm going to go ahead and factor this. Difference of 2 squares, so I get 0 equals x minus 2, x plus 2. And then I set each factor equal to 0, so I get x minus 2 equals 0, x plus 2 equals 0. And then solving for x, I get x to be 2 and x to be negative 2. So those are your proposed solutions. But since I raised both sides to even power, one of them may be extraneous. They both may be extraneous. All right, so you have to check. So let's check x equal 2 first. So let's do that first. So we're checking for extraneous. We're checking to see if any of these are false solutions, extraneous solutions. So let's check x equal 2. So always go back to the original. So I'm going to rewrite the original over. Square root of 2x plus 5 minus 1 equal x. So in place of x, I'm going to substitute 2. So I get the square root of 2 times 2 plus 5, subtract 1, and I want to see if that's going to equal x, which we're saying is 2. 2 times 2 is 4. 4 plus 5 is 9, so that's the square root of 9. And the question is the square root of 9 minus 1 the same as 2? Well, the square root of 9 is 3, and 3 minus 1 is 2. So yes, that is. So x equal 2 is going to be a solution. Now we got to check x equal negative 2. Is x equal negative 2 a solution, or is it extraneous? Is it a false solution? So let's check it. Check x equal negative 2. So again, you go back to the original. You got to write the original over. So here's the original. Square root of 2x plus 5 minus 1. And you want to see if that's going to equal x. So in place of x, you're going to substitute negative 2. So I get the square root of 2 times a negative 2 plus 5. Whatever that is, you're going to subtract 1 from it. And you want to see if that's going to equal x, which we're saying is negative 2. Okay? Well, look, 2 times negative 2 is a negative 4, isn't it? So that's the square root of a negative 4 plus 5. And then you're going to subtract 1 from that. But what is a negative 4 plus 5? Well, negative 4 plus 5 is 1. So I get the square root of 1 minus 1. See all these subtract 1s right here? But what is the square root of 1? Well, the square root of 1 is 1. And what's 1 minus 1? 1 minus 1 is 0. And the question is 0 the same as 2? And the answer is no. Those are not equal. So what that implies is that x equal negative 2 is an extraneous solution. So it is a solution to this quadratic. It's a solution to this quadratic. It's a solution to this quadratic. It's a solution to this quadratic. But it is not a solution to the original. So the only solution then is x equal 2. That's the only solution. This one is extraneous. And so that's a process you go through. Whenever you raise both sides of an equation to even power, you have to check for extraneous solutions. So you have to go through this process. All right, number 7. So this is number 7. And number 7, we have this for number 7. We have the square root of, let's see, 6x plus 1 equal 2 square root of x. All right, don't let the fact that you have two radicals on both sides throw you off. This is actually not a difficult one. Again, notice in both cases the radical is by itself, at least in this case. Let's look at this case for right now. On the left side, the radical is by itself, right? On the other side it is, it's just that you have a coefficient next to it. So just as always, let's go ahead and square both sides. Let's see what we get. So try something. Let's square both sides. All right, and notice in the parentheses I have 2 square root of x in parentheses. All right, and then remember the square and the square root undo each other. So you get 6x plus 1. All right, let's think about this right here. So remember, 2 square root of x squared means 2 square root of x times itself, right? Well, what's 2 times 2? 2 times 2 is 4. What is the square root of x times the square root of x? Well, the square root of x times the square root of x is just x. So that equals 4x. So this right here is just 4x. So notice I went from a square root equation to a linear equation this time. And so to solve this linear equation, I'm going to subtract 4x from both sides. And so I get 6x minus 4x is 2x. I get 2x plus 1 equals 0, right? 4x minus 4x is 0. And then subtract 1 from both sides because I'm trying to get x by itself. I get 2x equal negative 1. Divide both sides by 2. I get x to be negative 1/2. Okay, now we have to check. You go back to the original problem. So when I check, let's see what happens. Let me make sure I didn't make a mistake anywhere. This is 4x. Looks right. Okay, so let's check. Let's go back to the original. So we're going to check x equal negative 1/2. So I get the square root of 6x plus 1 equal 2 square root of x. All right, and so 6 times a negative 1/2 plus 1. And you want to see that's going to equal 2 times the square root of a negative 1/2. Now right away, you can stop. right away you can stop, because you see the square root of a negative 1/2? You cannot take the square root of a negative number and get a real number. This is not a real number. Okay, that's not a real number. So x equal negative 1/2, x equal negative 1/2 is an extraneous solution, because this is not a real number. And this is not a real number either, because look, 6 times a negative 1/2, 6 times a negative 1/2 is a negative 3. Negative 3 plus 1, see that negative 3 plus 1? Negative 3 plus 1 is a negative 2. So this is the square root of a negative 2. So that's not a real number either. So that's an extraneous solution. And since that was the only proposed solution, we say no solution. We say no solution. All right, so that was number 7. So that was a little bit more difficult to understand. So let's look at number 8. And that'll be the last one we'll do with this little part. All right, number 8, we have the square root of 2x minus 4 equals x minus 2. All right, so the radical is already by itself, so let's go ahead and square both sides. I'm going to go ahead and square both sides, just like this. And then the square and the square root undo each other. So you get 2x minus 4 equal, and then we're going to FOIL this, so I'm going to write this out, x minus 2 times itself. And then when I FOIL this out, x times x is x squared. The outer is a negative 2x. The inner is a negative 2x. And then a negative 2 times a negative 2 is a positive 4. Combining like terms, I get x squared minus 4x, and negative 2x and negative 2x and negative 4x plus 4. So that goes here. X squared minus 4x plus 4. Now notice I went from a radical equation, a square root equation, to a quadratic. So that's quadratic. So let's go and see this is quadratic here. So quadratic equation. So to solve this quadratic equation, I want to get 0 on one side. So I'm going to go ahead and subtract 2x from both sides. And notice I'm aligning my like terms. So this is 0. 0 to negative 4 is a negative 4, equal x squared. A negative 4x and a negative 2x is a negative 6x, and then plus 4. Adding 4 to both sides, I get this. I get negative 4 plus 4 is 0, equal x squared minus 6x plus 8. Now I'm going to go ahead and transpose the sides. I'm just going to switch them. So I get x squared minus 6x plus 8 equal 0. So I always prefer to get 0 on the other side. All right, factoring, we get x minus 4, x minus 2. So this trinomial factors into this. And so setting each factor equal to 0, my proposed solutions are 4 and 2. 4 and 2. So now you have to check, because remember you raised both sides to an even power. Since I raised both sides to an even power, you have to check for extraneous solutions. So let's check the first one, x equal 4. So you always go back to the original. So here was the original. I'm going to rewrite the original over. So here's the original, the square root of 2x minus 4 equal x minus 2. All right, so in place of x, I'm substitute 4. So I get the square root of 2 times 4 minus 4. And I want to see that's going to equal 4 minus 2. In place of x, I substituted 4. 2 times 4 is 8. 8 minus 4 is 4. So I get the square root of 4, which is 2. 4 minus 2 is 2. So notice those are equal. So x equal 4 is going to be a solution to the original. Now let's check x equal 2. X equal 2. So I'm going to rewrite the original equation over. Square root of 2x minus 4 equal x minus 2. So in place of x, I'm going to substitute 2. So here's what I get. I get the square root of 2 times 2 minus 4. And I want to see is they going to equal 2 minus 2. Well, look, 2 minus 2 is 4, isn't it? And what's 4 minus 4? 0. And what's the square root of 0? Well, the square root of 0 is 0. Well, what's 2 minus 2? Well, 2 minus 2 is 0 as well. Notice those are equal. So it turns out that in this particular case, both proposed solutions are solutions. I don't have any extraneous solutions here. So those are your solutions. All right. And so that is the idea of solving a square root equation. So in solving a square root equation, you're going to raise both sides. Since these are square roots, you're going to raise both sides to the second power because your index is 2. And always remember, whenever you raise both sides to an even power, both sides of an equation to an even power, you have to check for extraneous solutions or false solutions. Okay? So that's going to be the end of the review on solving square root equations.